Welcome back. In today's lesson, we will be looking at question number 1 from your assignment, and we have ourselves 40 volts connected with 12 ohms connected with 5 ohms and 4 ohms, as well as 3 ohms and finally 8 amps.
You're still in the game.
So now we are going to solve the current. So they want us to get the current I4 here. So they want us to get the current at that position, and we have to use superposition. So it has to be superposition theorem, right? So to solve that equation, what we're going to have to do is we have to divide the equation by 2, right? So we're going to have two formulas which will be much easier to solve instead of one formula. Okay, so we're going to have our 40 volts and we're going to have our 8 amps. Okay, so we have our 40 volts, then we have our 12, and then we have our 5, and then we have connected is our 7, right? And over here we have our 8 amps connected with 3 ohms connected with 9, sorry, not 9,
Oh my god.
connected with, sorry, connected with 4, then 5, and 12. Okay, so once all of those are connected, we need to find the current at 4 and the current at 4 here, and we're going to add those two. Okay, so we're going to add this one as well as this one to get our answer. So let's solve. So for the first equation, we're going to get our V total is equal to 40 and our R total is equal to 12 plus 1 over 5 plus 1 over 7 to the power of minus 1, and that's equal to 14,92 ohms, right? And that is our total resistance. So our total current is equal to voltage over resistance, which is equals to 2,68 amps, right? Therefore we have to calculate our voltage in parallel. It's going to be our current, total current multiplied by our resistance in parallel. So we're going to have 2,68 multiplied by our resistance in parallel is equal to 1 over 5 plus 1 over 7 to the minus 1, and that gives us an answer of 6,06 volts. So that is the voltage going through here and also the voltage going through here, right? Because voltage is equal in parallel, right? Voltage is equal in parallel, right? So therefore we're going to find the current, and then our current is equal to voltage over resistors, which is 6,06 over the resistor, which is 7, and then we get an answer of 0,866 amps. So that is our current.
Oh, my thing is not full, bro.
So for our next for our next uh, diagram, what we have is we're going to get our total resistance. So our total resistance is going to be, let's do it step by step. So it's going to be 1 over 5 plus 1 over 12 to the power of minus 1, which is equal to 3,52 ohms, right? That's our resistance. Then afterwards we're going to add 4. We're going to get once we add 4 we're going to get 7,53. Then our total resistance is going to equal to 1 over 3 plus 1 over 7,53 to the power of minus 1, and our total resistance is going to give us total resistance is going to give us, okay, we don't need to calculate the resistance because we only want to find the current. So let's redraw this instead. So we have 8 amps, and then we have 3, and then we have our 7,53. Now what we are going to do is find our current. So our current at 4 is equal to, so the current here is equal to the total current multiplied by the resistors in parallel over the resistor in parallel plus the resistor at 4. So the resistor at 4. So then we have total current, which is 8 amps, multiplied by parallel, which is our 3 over 3 plus 7,53, and we have a current there of 2,28 amps.
Yeah, we can go.
And then our final answer, our current is equal to, we're going to add this one, 0,866 amps plus the current here, which is 2,28 amps, and then our final answer, current at 4 is equal to 3,145 amps. So that is your current over here. So you can see that this is going top, and this is also going on top, and this is equal to 3,145, and that's your answer for question number 1. And I'll see you in the next lesson.